Um, Hello, dear students. Welcome back to our video lessons. Today, we're going to talk about the tangent function and its graph. This lesson is a kind of a repetition because you already know this subject from the ninth grade. So, let's start. Well, before starting, I want to remind you about this unit circle. So unit circle is a circle whose radius is 1. And also, what is the meaning of this word tangent? So in Russian, it means касательная. So tangent means that the circle and the line, straight line, has a common one point, or in other words, they intersect at one point. So the point is I'm gonna put it here. So this is so tangent in one point. So um, tangent. So now let me show you the what is the tangent function. So this red line, well, I'm gonna take it here as a tangent. So it's a little bit um, to the right side. So now it is. So this red line now is a tangent line. If you wonder what is the cotangent, well, I can show you also that one. Cotangent will be this straight line, but we are not going to talk about the cotangent, so we can erase them. So this tangent line. So from the previous classes also, you know that the ratio of a tangent in the right triangle is opposite over adjacent, or in other words, it's a rise over run. So rise over run. Well, you already seen the rise over run in the gradient function, so it helps us to find the gradient of a straight line. So it is. And well, then well, so let's go. Let's do this one. So as you see, if our angle is theta is given, and well, we have a right triangle, and in the right triangle, so the opposite side is our y. It's denoted here as a y, and the length of the run of this part adjacent side will be 1 because the radius is 1. So then the tangent becomes just a y. So well, I can show you in this way. So tangent becomes just rise over 1, so y over 1, just y. Well, you've already noticed that as the angle gets bigger, so the length also getting longer. So like as our angle getting bigger, so the length is also getting longer, and that's why. So for like we can say that as the angle getting bigger, the length of a tangent line is getting longer. For that reason, if I ask you to find, for example, tangent 90, you can say that it's an infinite. We cannot find because tangent 90 and the straight tangent line, like they don't intersect each other for that one, and that's undefined. We cannot find that one. They don't intersect each other. Okay. Uh, let's go for the next one now. What do you think? What if our angle is greater than 90 degree? So well, I can take an angle such kind of this one, and well, our angle should be this one. So this is greater than 90, approximately is 120, or this kind of. So you see our straight line is here and they don't intersect each other in this kind of question. So to find the tangent line, if we like prolong our line, so it intersects our tangent line at this point. So tangent 100, so greater than angle greater than 90, we can find this one. And as you see, that's a negative. That's a negative. under of the x-axis, so that's why the tangent between 90 and 180 should be negative. Also, the same thing works for the third quarter. If we draw an angle and we will prolong it to the opposite side, and it will get again the positive. Okay, well, this one, if we convert this given unit circle graph into the coordinate plane system, we'll get something like this. So let's talk about a little this one. So from 0 to the 90 degree, our function is increasing as we showed. So as the 90 degree, they will never get each other, so that's undefined. And the second quadrant, that was a negative between 90 and 180, so it coming from the minus negative to the 0, and then it continues again, like it's going in this way. And well, period of a tangent function, well, I am putting here the red line. So the period is 180. What does the period mean? Period is the interval of a function where the function repeats itself. So after this 180, it repeats itself, like again going up and from this one. So 180 is the period of a tangent function. Okay, let's go to the next one. We have some properties of the trigonometric functions. So here we have drawn this cosine function, sine function. Cosine is a blue and sine is a green, not green, yellow. And here we have a tangent. And well, as you see, as you remember from the previous videos, that cosine and sine are similar waves to each other. They just shift to the one side, and the maximum and minimum of points of these two functions are 1 and -1. Well, in the tangent function, we don't have a maximum minimum point because they are infinity, minus infinity, positive infinity. Okay, so let's go. So we have here some properties. Well, I will explain them. What is that? So firstly, well, as you see, we have written here 3 functions, and first function, they are not one-to-one, not one-to-one, and not one-to-one. So what does the one-to-one mean? So, well, to remember that, I have written here one function, which is y is equal to x squared. So let's put 2 points instead of x. The numbers are -3 and 3. So when I put them, the result of the both cases are the 9. So it means that 2 different points are assigned to 1 point, the 9. So this function is not one-to-one. This is many-to-one because several points are assigned to 1. So, like, to be a one-to-one function, for every point in a set A, there should be a different point in the set B. But here, as you see, we have the same points for the 2 different points, 3 and -3. So this is the one. This function is not one-to-one. So now let's come for the sine and cosine. So what does this mean? What's the relation between one-to-one? So as you remember, sine 30 and sine 150 are both equal to 1/2. So as you see, 2 different angles assigned to one number, one answer. So for that reason, they are not one-to-one. So the same thing works for the cosine and works for the tangent. So they are not one-to-one. The next property is the inverse. So we cannot talk about the inverse if the function is not one-to-one. To be inverse, they should be one-to-one. So for that reason, we don't have an inverse of this function. Or even if we want to find, we should restrict some intervals, but we will not do that one, so we don't have an inverse. The periods or repeats after. So I think you remember that from the previous lesson. We showed the graphs of sine and cosine, and the periods of them is 360. And about the tangent we talked today, sir, it's 180. This is the period. And the amplitude. What is the amplitude? Amplitude is the length of the, look, I will show it here. As you see, there is a red line, so it is the length between the maximum point of a function and the zero. So the same thing works for the cosine. So sine and cosine have the amplitude of 1. The same thing we cannot say about the tangent, because tangent goes to the infinity. So for that reason, it says here it's an infinity. That's the amplitude. Okay, well, I think that's all. The properties, tangent function. See you next lesson. Goodbye.